Aloha class, this is a video for exercise 11-5, net present value analysis of two alternatives. This company, Parrot Industries, has 100,000 to invest, so they have two projects. The working capital will be released for project B. So project B requires 100,000 of working capital. So we need to invest working capital, which is assets less or subtract liabilities, and then it will be released at the end of 6 years. So the example given in the textbook is cash registers for Nordstrom Rack, so they can use it for the time period of the project, and then it'll be released at the end of the project. So outflow at the very beginning, year 0, and then inflow at the very end of the project. Their discount rate is 14%. And so I've lined up the cash flows. Year 0 is today. For project A, they need 100,000 for the equipment. They're going to have cash inflows for the next 6 years. It's a 6-year project. And then a salvage value would be an inflow at the end of 6 years. So do look at the common inflows and outflows when we're doing net present value. I'm going to do, so these are the cash flows, and then this would be like the total cash flows. All of these together, we can have multiple cash flows in 1 year. So we have the 100,000 cash flows. So these are our cash flows, and then we need the discount rate. So you can set it up in timeline format, and then these are years on the top, so years. And then we're gonna need our discount rate, or we can do more of a vertical setup over here. And so let's do one way first. So discount rate 14% for 1 year, and the discount rate for today is 1.00, or you're not discounting it. And I'm multiplying the discount rate times multiplied by the cash flow. So let's do 14% year 1. I have my time value of money here. 14% year 1 is 0.877, and then year 2, 0.769. 877,769. And then year 2 and year 3, 877,769, 675,592. And then year 5 and year 6 at 14% is 0.519 and 0.456. Let me look, 519,456. Okay, and so if I were to sum up all, right, I've multiplied here, multiplied, and made it a discounted cash flow. Taking into account the time value of money. So if I have to wait a year, my 21,000 is only going to be worth 18,417 today. If I bring this back to today and the value it is today, and then I've summed up all of my inflows and outflows here. So sum them all up, and it looks like a negative net present value. So I would not want to invest in this project. It's not making me 14%. So net present value over here. Oh, and I have some white text going on. So net present value negative, do not invest. If you want to do another method, that could be a little bit faster. So we have this annuity. So you can find the discount factor using an annuity. So let's do the same problem, different method. This 21,000 is going to go on for 6 full years. So year 1 through year 6, it's an annuity. It's a constant stream of equal payments, and then it's 14%. Remember, 14%. So now I'm going to go down to my annuity at 14% for 6 years, and it's going to be 3.889. 3.889, and then that factors in all of the years. Multiply across, and then this is just 1 year, so that's at year 6, a one-time payment. So I want to go back to the top of my PV chart, one-time payment at 16%, 0.862. Or I could have found that over there. I already found oh, sorry. Did I do 16%? I wanted 14%. 14%, 6 years, 3.889. Okay, that one was okay. I just jumped to 16%. And it's year 6, 0.456. Double check, we had that 0.456. Okay, just wanted to check, make sure I get the right answer. So there's a little bit of rounding issues here, but your exam would be close. So what is it closest to? There can be rounding issues, but they're pretty similar. And so either answer is fine. It's not materially different from each other. That's approximately 7 plus 4, $11 difference. So very similar result. So definitely this one's good to do either way for your exam. So I wouldn't invest. That was the same problem. Two different ways. Now let's do project B. So working capital is going to be required in year 0, and then it's going to be released. So let's show that it is going to be released with the 100,000. And then we have annual inflows of 16,000. So these are all of our cash flows. Any other cash flows to worry about? 0 salvage value, 0 beginning investment. This is our working capital. So let's do total cash flows. Years, cash flows, total cash flows. Yep, similar format over here. So total cash flows equals the sum of those two rows. So those are our cash flows. Let's find the discount rate. Is it still at 14%? It'd still be at 14%. So we can actually reuse these discount rates, which is very fast and efficient. Thank you. And now we can use our discounted cash flow. So with this one, we have all our cash flow set up, and then we're going to sum all the inflows and outflows that have been discounted. So this one has a positive net present value, so I would want to invest. And then just remember, cash flows are laid out year by year, and then we had a release of working capital. Make sure you release it if it says it is released. I think most of the problems do say that they are released. And then we have the discount rate for each year and discounted cash flows that are all summed up. And so 7,808. If we want to do the more vertical format, I've listed out cash flow. This is working capital is invested and then it's released over here. And so this would be the one time at year 6. So I'm going to use that discount factor. And then this is an annuity. So we can use the annuity. Looks like 6 years, 14%. I can use that annuity factor. This would be today. And so similar answer. Again, we're off by a little bit. It's okay. This is a positive net present value, and then there's rounding issues. So your exam would be a number similar to one of those two, and that would be how we find our net present value. Thank you. I'll see you in class.